want to record on Zoom, so we're recording that. And then I want to share my screen with you, which is this one. Okay. And I want to go on here. Okay. Let me get you in the right spot and then we can go. Okay. Let me think about my intro. Oh, I'm so tired. Right.
Well.
Okay. Hello everyone, welcome back to Sparking Connections. It's another science episode. Woohoo, I love these. These are my favorite, obviously. So this week we're going to be talking about the scientific method. Now, I'm starting off with an Esmé question. Esmé, what do you know about the scientific method?
I feel like I should remember more, but it's the way in which, or the process by which we come to sort of develop theories and scientific understanding. And it essentially involves, if I'm remembering this right, developing a hypothesis, like observing the world, developing a hypothesis, testing that hypothesis, observing, whether those tests sort of display what you would expect and where they don't, and then developing a new hypothesis based on that, blah, 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 multiple tests over and over again until you, indefinitely, I suppose.
Yeah, just forever and ever. Yeah, that's right. So you're usually trying to prove something or disprove something. Usually there's this kind of bias in the scientific community where you don't publish results that disprove something. Like it's not intentional. It's just, why would you publish something that says, and I did all this experiment and it didn't work and it didn't show anything. So, but that's still valuable information, right?
Yeah.
When something doesn't work, that's still valuable information. So I don't know, but there is like a disparity between posting about or publishing about positive results and like things that are proven versus like posting things that have been disproven. So
yeah,
there's something to think about. But yeah, in general, you're trying to prove something, and usually this is done through like an identified scientific process. So there's like steps, as you said, there's steps, and we're taught at school these steps, which to me are pretty good, but they're pretty basic. So you have your, like you say, observations. They also call it description of a phenomenon, because way back when things were sort of like mystical and mysterious, so they were called phenomena. And then you go on to form a hypothesis based on that phenomena. So I don't know, the example I've seen is, my toaster doesn't work, or my bread isn't toasted, therefore my toaster must be broken. And then you've got to try and decide how you're going to prove that the toaster is broken. So is it the outlet? Is it the toaster? So then you would design and conduct experiments to test that hypothesis. So you'd plug the toaster into a different outlet, or you'd use a different toaster, or you know, like all the things that you would need to do to show that it's your toaster that's not working. And then you would kind of look at those results, come to a conclusion. So that's the very, very basic way that we're taught about science and like how the scientific method works. And to be fair, if you're not going to go into science, that's all you really need to know, that something has been observed and you've proven it or disproven it. But there's no mention really of like statistical analysis or like population demographic analysis, which obviously in terms of epidemiology is quite important, because, or like in anything really, like vaccine testing, all that, you need to make sure you have a representative sample and that the sample size is large, because otherwise you could just test it once and be like, yes, I am correct, I've proven that this is the case, and then someone else does it and they're like, no, I don't think so. So the scientific method in general is an iterative process. So when you do something and then you can change one little thing and then you do it again, then you change one little thing, it's like a lot of trial and error. And it used to be much more trial and error until we came up with machines that would, you know, run models of things, or that could repeat the process for you, so you only have to do it once and then it will do it over and over again for you. And the reason that it is iterative is because you want to minimize the biases that you might bring to it and that your equipment and your, you know, method might bring to the process. So we've heard of reliability and reproducibility, and repeatability and all these R abilities. So obviously, to make something reliable, you have to make it repeatable and reproducible. And those two words we are taught in school, but I just wanted to go over, you know, what they actually mean, because a lot of times you just learn them and then you're like, okay, whatever. So in science, repeatability is the ability to get the same or consistent results from the same person using the same equipment.
Right.
So, you know, when you do an experiment and you have to do repeats because you're trying to find an average.
Yeah.
Those repeats technically should all be the same, because if you're using the same equipment and the same person, then they should be the same. So repeatability can highlight human error and stuff like that. So if there's like big ranges, then, I mean, it could also highlight like a faulty machine or something like that. But a lot of times it's to do with human error. So we use that repeatability tests to make sure that our data is consistent. And then reproducibility is the reason we have an idea of reproducibility is because when you publish a paper with the methods and the all sorts of things like that, you want other people to also get the same results as you. You don't want people, you don't want to do the experiment and then other people do it and be like, nope, I didn't get that and I didn't even get anything close. And then you tell them, oh, but I did this, not this. It's like, no, all that information that could possibly make someone else complete the process differently has to be included in your journal article, report, whatever. And that's so that it can be proven by everybody in every case, in every situation. So as you can see, you have to kind of narrow down the process very, very, very specifically. And it becomes a lot less about trial and error and more about the sort of consistency in which you can complete a process. It becomes a lot more like technical as opposed to, you know, designing ideas and that kind of stuff. But it wasn't always that way. And I thought I would just go over, I mean, there's a very long history of the scientific method and science in history in general. And the sort of trial and effort, the sort of trial and error method didn't even start with like scientific experiments. It started with the extraction of metals before pre-Bronze Age. So they were taking metals that they found and were like, could I use this for a process that makes tools? Or could I use this for a process that makes cutlery? I don't know, whatever you want, plates, bowls, crockery.
Weapons are the usual example, aren't they?
I mean, to be fair though, the paper that I was reading said that a lot of the gold and silver and copper were too soft pre-Bronze Age to make weapons out, so they used stone. That's why it was a Stone Age, obviously. And so it took a long time for them to sort of work out and trial and error how to make these metals more, like to strengthen them or to make them more efficient in the role that they wanted them for. So copper, for example, I think the Babylonians decided to like beat the metal with a hammer to like mush it because it was soft, so it would be like squashed, and that would actually make it stronger because they would be breaking the current crystalline structure so that it was like pressed close, all the particles were pressed more closely together, so then it would make it more solid. Sense. And this is actually, people consider this an early form of nanotechnology, like having that idea that if you press the particles closer together, then it's gonna make it stronger. So that was kind of one of the first trial and error steps, was they were like realized that, oh, if you press this metal, it's going to be stronger. And then the introduction of tin and other metals to make copper stronger. So there was I think they found some copper spearheads that were like an alloy of copper, and it was like 76% copper, a couple percent tin. There was some other like more less well-known metals, but all in all it made like a stronger, more usable metal for weapons. And that's what the Bronze Age became known for, was alloys, because they needed to make bronze, and bronze is that mix of metals, copper and tin and all that kind of stuff. They also used high temperatures to make metals, so they discovered that high temperatures would be able to separate metals from their impurities. And again, that was a trial and error process.
Yeah.
So this sort of comes under a sort of mix of chemistry and maybe like geography kind of thing, like stones and
Geology
metals
and
and yeah, kind of. So they would very quickly learn, oh, these are going to be better metals for decorative things. So gold and silver was so soft that they would use it for decorative things, and it took a lot longer for sterling silver to become a thing and all that kind of stuff. So that was one of the first instances of like a kind of semi-scientific process being used. It was more of like we're going to observe and this is what happens, therefore we're going to keep doing different things to see what the outcome is. And then moving on from that was early medicine. So similar sort of, obviously in the Bronze Age, people didn't live very long. So early medicine, kind of important. And that was also trial and error, unfortunately. I mean, you don't really want medicine to be trial and error, but it was. And it was often herbal remedies, or like herbal remedies that could cure constipation, or I don't know, other things that you could possibly be cured by eating something that's going to make you sick. And then you're like, oh, I'm recovered now because it's, you know, all the whatever it is has been purged. But the other alternative to a herbal remedy was a supernatural origin of illness, which we know then found root in religious like contexts. But for the most part, there was a link between like giving a herbal remedy and then chanting and dancing to kind of help the process, as it were. And so it kind of became linked in a way that was like, well, I gave the herbal remedy and I chanted and danced and they got better. But it could have been the herbal remedy. Don't necessarily know if the chanting and dancing would have helped.
You're not going to take your chance and like just do one of them, knowing which one it was. You're going to do both just to make sure.
But that also had an interesting impact in terms of the placebo effect. You know, people gathering around to like chant and you know, maybe pray over you, or offer gifts on your behalf, things like that would sort of make, I don't know, having all that attention would make you feel better. You would, in your mind, you would be, oh yeah, these people are, you know, providing this attention, this energy towards me, so I must get better. And sometimes that would make people feel better due to the placebo effect. So not to say, because I know there are people out there that are like, you could just think yourself better. You cannot just think yourself better. Just to make that very clear. But there is some positive benefit of having like positive thought and, you know, trying to push yourself to do things that will make you feel better, if that makes sense. In terms of like mental illness and stuff, like exercise does help to make you feel better in your brain, but you're not going to necessarily do that unless you can actually get the will to do that. So it's kind of like, so it was kind of a similar thing. They were like hyping you up, basically. They were like, yeah, you're going to get better, you're going to get better. So in your mind, you're thinking that you're going to get better. However, the supernatural origin stuff, as we well know, led to things like trepanning and leeches, bloodletting, which I mean, people still use leeches today. I don't know about trepanning, but people still use leeches today. It's one of those alternative methods now. You know, when you go to a spa or like a health clinic, and then you get leech, like it's like a new age. It's been brought into the new age. But we know that a lot of the things that that were done to people also caused other infections. So, you know, bloodletting and stuff could often lead to septicemia and other blood-related illnesses. And then, of course, we're in a kind of stuck in a circle of, oh, and it's a supernatural disease and it's of the blood, so we need to let more blood. And I think there were quite a few people that, I think George Washington had his blood let shortly before he died.
What a coincidence.
I think he had a stroke or something as a result of like low blood volume causing a clot or something.
I shouldn't laugh. It's tragic, but like
it's tragic. And there's so many instances of that kind of stuff. And you're right, it kind of makes you cringe a little bit. So even though early medicine was a part of trial and error, there was also punishment for bad doctors. And there was a passage that said that if the abscess, there was something about an abscess, if an abscess is removed and the patient dies, so in effect you make them ill from doing an operation, which is pretty common in way back when, then you would have a hand cut off. And as a doctor you kind of need your hands, so so there was actually quite harsh punishments for doctors that did a bad job, which, I mean, accountability, we love that, but also losing a hand?
Yeah, in a world before, like, antibacteria, what's the word? In a world before the kind of sanitation that we have now.
Right.
To blame someone for getting infected, it's
not it, is it?
No.
So yeah, that was kind of I wouldn't say a long-standing tradition, but people definitely did it quite a lot. There was, you know, people wrote about it, or at least the threat of it. There was also the I had to include this because it makes me laugh because it's so tragic. In Babylonia, when Babylonian people, is that what you would call it? The Babylonian times, people would leave their sick on the street, on outside their houses on the street, for amateur physicians to walk by and decide what was wrong with them.
Oh no, that's such a bad idea.
It makes me laugh because it makes me so concerned. How did we live through this? But yeah, people would just be left in the street if they were sick, and this people who claimed themselves to be amateur physicians would come up and have a little look and be like, oh yeah, I think it could be this, and then they would, you know, do a procedure and that would be that. Concerning. There was also interestingly, in Egypt, even though embalming was a big thing, they didn't actually know that much about the human anatomy. You know, they didn't, I don't know, maybe they were just like, well, embalming, okay, it's a process that we do, and like nobody thought to like analyze the heart or analyze the organs that were removed and put in the, you know, the jars. So it kind of took quite a long time for people to really get into human anatomy and stuff like that. And obviously in later British history, there were many institutes that would take cadavers and sort of analyse the insides of people. And in ancient Israel was actually where the foundation of public health came from, because there's a huge amounts of writings on personal hygiene and social hygiene, so like social health responsibilities of not leaving things in the streets that will get other people sick and stuff like that, which obviously took, again, in the UK, took a much longer time to be introduced because we were using the River Thames for a lot of things, which we probably shouldn't have. And then also, ancient Indian physiology was based around what the Greeks called the humours. And I know we mentioned the humours before. They had similar, they had different names for them, but they had similar, you know, sort of the bile and the blah, 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 blah. So all the 4 parts, I think it was. I think they also had 4 parts, which they were the same as the humours. So that is also interesting, considering ancient India and ancient Greece weren't in the same place. They were very different places. So after this sort of early medicine, I thought I would talk a little bit about the Greeks. And so early medicine was a lot more practical, right? You had physical things that you could do and physical tests that you could see on people. And the other thing as well is because it's on people, you know, you're witnessing people dying, so you're kind of trying to find a cure for it. It's not necessarily trial and error in terms of, like, you can do the same experiment on the same person over and over again, because if you do it wrong the first time, they're going to die. So it was more about survival, let's put it like that. It was more about survival and doing what you can to find a way for someone to live than it was about learning things.
You weren't really going to have labs and such.
No, right. And Aristotle and Plato were the ones that came up with sort of logical ways of explaining things. They might not have been right, but it's where the thought process came from of this is this, therefore this is that. Do you know what I mean? Like, it was a more balanced approach. So there were observations without interference, and then you had to sort of organize what you saw into the theory that you're trying to prove, basically. So they didn't change anything. They didn't do controls. They didn't do anything like that. They just watched things and observed things and then organized those facts, which obviously is only part 1 of what we now consider the scientific method. But you can see that's where it came from. Observations are extremely important in understanding the world around us. And then you would also only display the important changes. So there's that bias again. If you only talk about the things that you've seen or demonstrated. There's also Pythagoras. We all know who Pythagoras is. At the similar time, he was introducing maths to explain the world. And also poets would describe observations about the natural world. And I threw this in because later on, the Romantics are one of the reasons why the sort of Age of Enlightenment was allowed to happen. So I'll get onto that in a little bit. But poets had a very important role in sort of describing and observing things about the natural world. So talking about like fire and the way it moves and the way its impact and that, you know, has a scientific basis, and changing of the seasons and how water moves, things like that. So that was all, you know, impacting the thought processes of people around us. And obviously people were more likely to read poetry than they were to read scientific sort of theories. So it kind of opened up the lay person's eyes to the natural world, basically. And also there was a huge amount of progression in everywhere else, you know, because I feel like we'd always taught about the UK and sort of that early European aspect, but soap, gunpowder, loads of other things were developed elsewhere that we then came across as European colonizers. We then came across and, you know, we're like, oh yeah, this is a thing now. But it took people that same trial and error process to find. Understanding that one thing can be made into another, and that new thing may have new properties. And that was all done through observation as well. So in the 13th century, European universities started to shape what we now know as modern science. So that's where you do an experiment, and then you change something, and then you do another experiment, and then you compare those results. It's called evidence testing. And you would do that you know, you have to get your idea for evidence testing from somewhere. And so you would observe the world, and then you would be formulating questions based on those observations.
Mm-hmm.
In the 16th century, however, progress was slowed by religious intervention. Moment of silence for those people. But, you know, they still had a lot of the resources for early medicine, right? They were the ones that were taken sick and help them. And so they had a lot of valuable information, but they had it in a more supernatural, they sort of had that supernatural bias, as it were.
Yeah.
Because they thought that sicknesses could be exorcised and so on and so forth. And people still do. And, you know, hey, as long as it makes you feel better, you do what needs to be done, as long as it's not hurting anybody. So it was also at this time that Copernicus decided that the Earth orbited the sun. I say decided. He said he had evidence, but, you know, can we stand by that evidence? We can now, as a result of later 17th century equipment, but he presented the idea. And obviously, again, people thought he was ridiculous for deciding that because of that religious bias. Interestingly, the 16th century was also the discovery of the creation of the printing press, which meant that a lot of information could now be published. And so it became a lot more involved, again, more lay people involvement and more sort of public engagement with the information that was being presented.
Yeah, the printing press is such an important invention. Like, it's not one we think about. And it's not one of the ones that's like really interesting or whatever, but like it's so important in like in every field.
Right, because if you have information, if you don't share it, nobody's going to know about it, right? So then we move on swiftly to the 17th and 18th centuries, modern science, visualizing equipment, so microscopes, telescopes, all sorts of things that would allow us to prove scientific laws. So this was the 17th century was when gravity was proposed, how temperature of the gas is linked to pressure. So you increase the temperature, that increases the pressure of an object with gas inside. And then finally we reach the 18th century, which is the Age of Enlightenment, which is called the Age of Enlightenment, but a lot of people also refer to it as the Age of Reason, which I'm like, were the people before unreasonable? Not necessarily, but this is the time when biology and chemistry became fields of study, and as I mentioned before, rise of opposed movements such as Romanticism. So it became things that you didn't believe or things that you didn't agree with were becoming more popular. So in the social context, science would have been in a similar vein of, oh, I don't know about this, I don't know if I believe this. But because a lot of other alternative movements were coming up, people were more inclined to give it consideration, if that makes sense. People were primed to expect the unexpected, and therefore the introduction of scientific ideas that were a bit more obscure were more accepted. And then we get into more recent times of the Industrial Revolution, and we get the theory of evolution and electricity. And also in the 19th century is when we got introduced to statistical methods, which becomes another new component. So we've had observations, and then next we've had the experimental process, and now we're coming into statistical analysis. So this is a part that we're not taught necessarily in school, but it is actually really important to people completing scientific experiments that they want to be published and things like that. So using observational methods, data would be collected and then analysed, which would then lead you to hypothesis forming and so on and so forth. So like I said before, with population dynamics, you know, number of people moving here and there, or counting the number of cells of something, or it became a lot more numerical, which is important because you need to be able to compare. The easiest thing to compare is numerical data between one variable and another. And you can also test to see if that is significant. So whether the reason for it being different is random or not. And then finally, 20th century and beyond, we've had quantum mechanics. Human Genome Project was a really, really important sort of corner to turn, if you like, in this scientific community. But we always have to come back to how modern methods still need someone to be imaginative or creative or observe something that they want to change, you know, or to understand, which is difficult to teach. So unless you observe something and have a question about it, then it would be very difficult to be a scientist, if that makes sense. Not to discourage anyone that isn't super creative, but I didn't think I was creative and I'm a scientist, so what can I say? There's also an increase in computer methods. Now, I wanted to talk a little bit about the black box principle. So you've heard of a black box, right? Yes? No?
In terms of like, I've heard the phrase black box in people complaining about social media algorithms.
Yeah, okay, that's a good example.
In the sense that it's like, if I've understood right, there's a black box, sort of, we don't know what's in it, and so we don't know how. We know that we know what goes in and what comes out, but we don't know what's happening to it.
Yes,
which is frustrating for people trying to use that thing.
Right, exactly. So the issue with science and the black box principle is that we have, you know, modern machines now that run processes for you. You don't necessarily have to understand how it does it to prove something, but then how do you explain your theories and you know, bring a conclusion to your theories if you can't explain how you got from input to output? So there was kind of a move to get all these technologies taking off, and then all of a sudden there was a move for people to gain information about those machines. So a lot of times people would get the machine, run the process, and they'd be like, look, it works, but they couldn't necessarily reach a conclusion because so few people had an understanding of this machinery. And that's still the case today. You know, there's very specialized machines that only a few people know how it works. And so it becomes a bit more restricted. So we've kind of we're almost going back on ourselves, where it used to be a few people and then a lot of people knew about science and then fewer people again. So the three principles of the scientific method, according to history, are theoretical reasoning, experimental practice, and then someone also just suggested that computer simulation is the third. So because of this black box principle, and because we're trying to find new methods to analyze and understand data, because we've got such massive amounts of data, like so much data, then because if you think about it, someone does an experiment, they collect a bunch of data. They're only going to use the data that's relevant to their thing, right? But that doesn't mean that all the data related to that thing doesn't exist. So you could draw conclusions for multiple different things from the same set of data. And people post data online, and then other scientists can just take that data and come to their own conclusions and to do their own analytics work, which is sort of becoming more of a tapped field now. So it has been suggested in recent times that computer simulation is the third pillar of the scientific method. But as you can see through history has helped to shape what the scientific method is all about. And when we reached a point where schools teach science, right? Because, I mean, we probably have taught science at least since the 18th century, even maybe earlier than that, you know, because before it was a very sort of obscure thing to want to do, right?
Yeah.
Instead of being a farmer, you would think about observations of the world and things, and people would be like, no, get back to work. And then as we progressed and science became more of a thing, men were encouraged to pursue sciences. And then obviously over time it became a bit more equal. But it doesn't mean that our science education represents the progress that we've made since teaching science, if that makes sense. So obviously we have the historical context of science and how we got to that place of science. And the scientific method that we're taught in school stops at you draw a conclusion, or you make an observation, you do an experiment, you draw a conclusion.
Yeah.
Because there is no statistical analysis, because there is no use of machines, in science in school, you don't have a machine that you enter samples into and it comes up with an output. There's no sort of understanding of the black box principle in terms of science. And it also led to a more sort of hierarchical view of science. So you've got science that you can physically do, and then science that you theoretically do, and then sort of science that you can model. So science that you can physically do and physically prove became almost rudimentary looking, quote unquote, because you physically had to manipulate things to cause a reaction. Whereas a sort of more data or machine-led model might be seen as more intellectual, because you're not actually, for example, ecology, where you have to actually go out into the world and observe things and get in the dirt or dig up a plant or observe a bird, that was seen as more rudimentary compared to sitting in front of a computer and modeling an outbreak, or modeling something, I don't know, modeling a body's enzyme system or something like that, because everyone could potentially observe the natural world, but you'd still have to be trained and you still have to have a certain degree of knowledge to be good at ecology. So that kind of hierarchical view doesn't really make sense, but as we know, biases don't have to make sense. So data-driven science was seen to be better than observation-driven science, and that kind of pushed those observation-driven sciences away from what is now being considered like cutting-edge science, even though we're trying to use plants and fungus to come up with new antimicrobial drugs, which is what we did way back when. When Fleming was like, oh, I've got mold and this is, killing bacteria. Cool. That means there's something in it that will cure people. We're getting back to those roots. I mean, we're using modern processes to do it. We're running whole genomes. We're doing that black box thing where we put a plant into the machine and it reads what the plant does and then spits out an output. And okay, yes, we have to interpret that output. As I've said before, you can only find what you're looking for. But we're still, we're coming back to those sort of observational roots, as it were, which is really kind of fun, because then you can actually do physical experiments again. And that's what I like about microbiology too, is that it's quite physical. So, you have to dip your loop in something and then plate it, and then you see the growth and you can make observations about that. So instead of observation being seen as a sort of preparatory phase, it's now coming back as a more viable method of discovery, as it were. And then I also saw an interesting article that said that concluded that self-awareness is the reason for, quote unquote, the start of science. And I wanted to discuss with you that. What do you have to say about self-awareness being the start of science?
It makes sense. I think self-awareness in terms of knowing that there are things that you don't know yet, and like observing where the gaps in your knowledge are, and understanding yourself as an observer and as an agent sort of in the world. you know, that looking around and realizing things aren't just happening to you, you are physically affecting the world around you, and therefore able to sort of make changes and observe the results of your actions.
Yeah.
And to realize like that there is information you don't have, and that it is out there, and that you can go find it, that you can experiment and such, as opposed to the sort of the attitude that's like, there's a thunderstorm, the gods are angry with me, oops.
Yeah, right. It's like you can't, and also back when that ideology was more prominent, there's a, did you hear that?
Yeah.
Back when sort of upsetting the gods was more of a prominent ideology, it wasn't as if you could pull out any equipment that would prove that an earthquake or a storm was as a result of, you know, anything other than a god, because you just didn't have the means to test it. So I guess having self-awareness of that aspect is important. But could you be doing scientific experiments and not be self-aware? Like, you could be trying to prove, I don't know, I guess the very nature of proving something means you're aware, but are you self-aware? I guess you would be. You'd have to be.
Yeah, I mean, I suppose you could be doing some level of trial and error in terms of, because I think there's trial and error that's like on a purely survival basis. I am hungry, I will eat the first thing I see. Oh no, it made me sick, I'll try again.
Yeah.
Like, you know, there's the very basic trial and error that every non-human animal can do. But then there's wanting information sort of beyond that. There's a difference between trial and error, which food is going to kill me and or make me sick. If it kills you, that's the end of your trial and error, isn't it?
Yeah, right.
Versus like, I have a tool, but I want a better tool. What can I do to find out how to make one? You know, like, I feel like that's where the self-awareness part comes in, that you are aware of yourself as an agent who can change things, as opposed to just trying not to die.
I guess also you could say that self-aware, well, where would you put, this berry looks similar to that berry that made me sick, therefore it probably will also make me sick? Because that's very self-aware, but still a survival trial and error.
Yeah, I mean, ultimately, all of it's about survival. Like even now, when we consider ourselves to be like sort of enlightened past that point where we're not, you know, we're not just focusing on mere survival.
Yeah.
Medicine is about survival. Medicine is about, how do I make this disease not kill me?
Yeah.
So yeah, it's hard to say. I suppose there is a difference between, I don't think there isn't like a hard and fast, like a thin line between, you know, trial and error for pure survival purposes versus self-aware experimentation. But like, I somewhere there is a gradient that we must have
passed
reached.
over, passed through that gradient. I agree. I think that being self-aware helps. And I suppose it could have been the start of science, but it also became the beginning of a lot of other things. And therefore those other things could have also impacted the start of science, as it were. So, yeah, I think it's difficult to pinpoint one thing as the start of something else, especially in history where, you know, accounts may not have been, well, accounts are never reliable, especially personal accounts, but accounts may not have been well recorded or been recorded in a way that we wouldn't interpret it the same way nowadays as well. So yeah, but I wondered if you had any questions or any other things any things you wanted to discuss from what we talked about.
I think it's interesting to look at where science has been sort of impeded, but more generally where there's conflict between scientific fields and other fields, and also within science. So like you mentioned the Romantics, and sort of, because the Romantics weren't anti-science, but they were, on the whole, obviously this is a huge generalization, but a lot of Romanticism was pushing back against the Industrial Revolution, and came out of like the Enclosure Acts and things like that. And I think there was a sort of this idea that science was reducing humanity.
Right.
And not all science, but there's this sort of, I suppose, science in the name of industrialization.
Right.
And sort of factories and such. And there is this sort of idea amongst, certainly by no means all creative people, but sort of a trend that some creative people end up falling into, that's like, science is useful for certain things, like science is useful to stop us getting sick, but it's reducing humans down to, you know, something like less special. Like it makes us less special.
Right, because we're just particles special, or bones or organs. So but yeah, we're being reduced down to like our constituent parts, as it were, not necessarily the spirit of what we present, I guess.
I'm out of throat sweets and I
oh no. But yeah, so yeah, I can see why. But then science in itself is a creative process. You have to think outside of what you know and imagine what is possible, or possible to try and prove, you know.
Yeah, but like science has informed art and art has informed science. Like Keats was, you know, training to be a doctor before he before he started taking writing more seriously, and also before he just got too sick to do anything,
because tuberculosis, man.
But like, you know, I don't remember who wrote this essay. If I find it, you can cite it. But about how botany was an important part of the sort of training to be a physician, and a lot of Keats's writing draws on that, like uses the scientific terms for things, uses, you know, the scientific terms of the time, and has a more accurate depiction of like which plants are in a certain place. You know, you're not just going to choose the plants that sound nice when you're describing the field or something. You're going to choose the ones that, or with this training, you're able, or with a more scientific mind, you're going to pick the ones that actually are in the place you're in at the time of year you're talking about. And if you deviate from that, it's going to be for a particular reason. But like Percy Shelley was very into, you know, sort of doing his own little experiments. You know, various writers in that time were interested in science. It wasn't like the Romantics were anti-science, but they were more skeptical of that sort of like cold reason, you know?
Yeah, totally.
And I think that's something that's carried on. But the way that you describe the scientific method, it doesn't have to be that. Like there's, you know, observation is not incompatible with, like you can observe and appreciate at the same time. You don't have to, you're not reducing everything to numbers.
Right. I mean, you know me, I love being outside and nature and things. I mean, to be fair, ecology isn't my specialism, but all the ecologists I've met love nature for what it is. They're not looking at a population of birds and being like, yes, and this many birds means that, oh, this is low for the season, and blah, blah, blah. They just look at the birds and they're like, these are amazing creatures. So
but also understanding those things enriches your ability to make art in the first place.
Yeah, definitely.
Because you're observing patterns in things and drawing on that for your creativity. Looking at everything and just going, well, it's pretty, but I don't have a clue what it does, is not, it's not as interesting.
Yeah, not enriching, as you say. I mean, and also mathematics comes into it too. A lot of the natural world is in, you know, has a almost numerical format. I mean, take Fibonacci, for example, like sunflower petals and snail shells are all represented by what Fibonacci had to say. So, you know, to me, it doesn't take away from the beauty of it. It just boggles my mind that I'm like, this is a scientific process, a method that people have proven, and it's almost, it makes it more unbelievable that you've categorized it or you've understood it. So yeah.
But do you think that some of these, like, that are looking at things through a mathematical lens or through basically, okay, how do I phrase this? As science has progressed and we've developed a scientific method, do you think that that could also limit us in terms of what we can discover about the world? That, like, this is the scientific method and any deviation is wrong, and so we can only see a certain, that, like, the conclusions we draw are coloured by the process that we use, and therefore there are things we're missing. You know, do things fall through the gaps, or do we misinterpret things because we're looking at everything through a particular lens? Like, I
would say 100%. And like I mentioned before, that's proven by the fact that we're having to return to original methods to find antibiotics. You know, we progressed so fast in making our own antibiotics and designing antibiotics, you know, by chemical synthesis, that we lost that root of where they actually came from. And we're kind of returning to that herbal remedy idea. And I think that really proves that maybe we, as a science, you can get kind of not necessarily lost along the way, but you need to return to where you came from to progress even further than what you've done before. Because obviously chemical synthesis of antibiotics is a phenomenal way to design antibiotics and has become so beneficial to so many people. But as we enter this age of antibiotic resistance, and I mean, we're in it, and as we progress through it, you know, we need to look back on what we've done before and try and optimize it. But yeah, I think definitely you can lose touch, and you can lose touch with your creativity and your innovation. I think that's maybe what the most important error that could be made is you lose touch with your place in the world and your point. You know, you're so fixated on one thing, especially with further study and research and stuff like that. You know, you can kind of lose touch with how your research fits into the world. And at that point, you know, are you really doing something that's worth researching? And obviously, if you find that reason, then go forth and continue. But, you know, sometimes you've got to wonder how far to take research that isn't really necessary at this point in time. Do you know what I mean? Like, not to say, like, if you're doing research that is pointless, that you forget it forever, but some people will do research in the name of research. You know, think about Frankenstein, right? He was just doing it for the sake of doing it, and you've got to wonder how that helped or impacted the world. It didn't help the world in any way, but his impact was
then again
vast.
Yeah, but then again, you can, if you're doing research just for the sake of research, like you've just found something and you're personally just fascinated by it, you have no idea whether something useful could come of it in the end.
True.
Like, how many things were discovered by accident, you know?
That's really true. Yeah, I mean, penicillin was discovered by accident.
Yeah.
But I think that it's not that you should stop research if it doesn't seem like it's going to fit in the world, but knowing when to shelf that research for when it becomes more relevant, if that makes sense.
Right.
Like writing about it and thinking about it and discovering it, yes, do it, always do that, but knowing when to like force it into the mainstream is also a fine line.
Yeah.
Because once upon a time, like, organ transplants were thought of as like disgusting and horrific, and it just wasn't the right time because we didn't have enough information. So it's knowing when to put that to the side and come up with other, they came up with blood transfusions and other things instead, and then went on to then continue doing organ transplants when they had more information. So it's knowing when to sort of shelf research and come back to it when it's more appropriate.
Yeah.
Do you have any other questions?
Don't think I do.
Okay.
It was an interesting, that covered so much that I don't know what to zoom into to do a question.
I wondered if you had any things, I know you've done a lot about the Greeks and things, and I just wondered if you had anything you wanted to ask in terms of, or had anything to share about the Greeks and their ideas of medicine and science.
It's been quite a while since I studied anything relating to the Greeks, and even longer since any of that was anything other than their literature and plays. But I think what's interesting is that, like, the way that the ancient Greeks conceptualized science was so different. That we separate science and philosophy. And, well, we now tend to separate philosophy and theology. Those three things were not different to the Greeks. It was all the same process. That's why when you were talking about ancient medicine and ancient science, you were talking about people we consider philosophers. That Aristotle would have considered himself, if the word scientist existed, he would have considered himself a scientist, I think. Yeah. It's also,
maybe he wouldn't have been a good scientist.
Well, who knows? But Aristotle's writing covers what we would now consider science, philosophy, literary criticism, politics.
Right.
And I think, I don't know, it's interesting that we now have these very discrete branches, which is partly because knowledge fractals, right? Like, once you know one thing, there's then 1,000 other things to learn, and in order to specialize, you have to separate things into more discrete categories. But I do wonder whether something is lost in that respect, whether there's I don't know, whether in the future we will go back to that more classical understanding or idea of all of these things being interlinked, because, we talked in one of the Autumn Journal episodes, I'm not sure whether we'll have got to it by the time this goes out, about Aristotle's ideas of, like, the person or the man, because, in society, and how, man gets his purpose from the world around him and from the other people around him, specifically from the polis, from the city-state. Yeah. That you're like, that who you are, your identity, is based on that purpose, and that purpose comes from the people around you. And, that has implications politically and in psychology, and psychology affects medicine. Yeah. Yeah, totally. And all of these things are sort of interlinked, and we the way that we now separate them has uses. Like, I am not saying, oh, we've gone the wrong direction, everything's
right.
I'm just saying, there is it's a different way of thinking, and it's interesting that we've changed that side of things so much. And I do wonder whether we will eventually I wonder whether we'll keep specializing and specializing and specializing, and suddenly there'll be 5,000 types of biology, or whether we'll eventually, we already have cross-discipline things.
Right, as I was going to say, we draw back and become more
yeah
broad. I think we've talked about this, though.
Like,
we talked about, do you remember we talked about, I don't know, it probably wasn't on an episode, it was probably just a conversation that we had about how, you know, we were in the same science classes together, and I chose science as a career, and I went deeper and deeper and deeper into science, and it became more and more niche until eventually what I think of as common knowledge, or what I think of as knowledge that doesn't need to be explained, or that, you know, terms that I don't need a definition for explicitly, becomes my normal. And you did the same. We were in the same English classes together, and you became more and more specialized and specialized. I mean, it was one of the reasons why we came up with this as a podcast concept, was because so many people, you know, scientists, as they get further and further away from the layperson, lose their ability to communicate back what they know, because you lose that language in a way that people understand, and, like, you know, you lose that ability to explain to people, to help them understand. So I think it definitely, in terms of, you know me, I think people should be in control of all their, you know, their science and their knowledge and things like that, because it impacts, you know, especially medicine, it impacts you so much that I feel like it will eventually have to come full circle and be something more broadly known. You know, in terms of this pandemic and personal hygiene and all that kind of stuff, you know, we kind of lost why we need personal hygiene. You know, it's just a given that you wash your hands, but to some people that given became so diluted, and the reason for it became so diluted, that all of a sudden people were having to be told to wash their hands again. So
and the sort of the importance of that is not just a scientific issue, it's a humanities issue as well, in terms of, like, you know, that a scientist can tell you the bare fact that washing your hands with soap for 20 seconds will kill this many, you know, this percentage of the germs, and therefore was
prevent spread,
prevent or significantly slow down the spread of disease. And the humanities will tell you, here's 50 different philosophers telling you why you should care about that, for whatever reason, for theological reasons, or for other sort of secular ethical reasons. And the two disciplines really have to communicate, and quite often they don't, but it's more likely actually that a scientist can tell you their favorite Shakespeare play than a literary critic can tell you anything scientific that they like.
Point.
This is brought up by one of my lecturers. I did a literature and science module at uni, and one of my lecturers pointed this out, and it's just like, oh crap, like, my scientific knowledge is not good. Like, I'd say that I'm a reasonably intelligent person, like I can look into this stuff and understand it, but it's definitely not something that I know a lot about. But also just the way that we sort of frame these as two separate ways of looking at the world, but they're really not.
Not at all.
And maybe they could learn from each other, not just in terms of using scientific ideas in literature and scientific innovations being inspired by books, but like the actual ways we look at the world, and how we how we understand our place in the world, and our sort of ethics, and, you know, everything.
The language we use to explain things, and our ability to use art in a way that informs, you know. We have to use this kind of stuff in science, like we have to make posters, you know. That's a very artsy thing to do, but, you know, you have to present your information in a way that people are going to understand, and it needs to be aesthetically pleasing. That's a big thing that we are taught, but we still don't think of science as having any kind of artistic integration, and it's nonsense.
And like the metaphors that we use in science to, you know, I believe it was Susan Sontag whose essay I read about like using military metaphors for preventing disease, and the potential implications of that, you know, there's all kinds of implications of that. So that's a whole separate podcast that we could do. Or the you know, the way that we explain so much science to children involves, you know, atoms, right? The electron wants to do this.
Personification, yeah.
And personifying things works up to a point, but is that partly because in the humanities we're so used, like novels are 99.9% of novels are written from a human perspective, or from an anthropomorphized animal perspective.
Yeah.
What can we, if the scientific fields are trying not to humanize natural processes, you know, how can that mindset affect literature? And how can, you know, how could what would happen if we went back to personifying things in the natural world? What effect would that have on how people perceive climate change, how people perceive the animals going extinct?
Cancer,
versus how,
like anything that has a huge sort of health impact. Yeah.
Or how would it affect the humanities, you know, philosophy and ethics and literature and everything, if we take that scientific, like not humanizing things mindset? You know, what happens when you perceive people as more mechanical versus as things with souls? Like, you know, like it's
definitely.
I don't have any answers or any sort of points to make. It's just a thing thought that I'm thinking about. Yeah,
it definitely, they definitely impact each other, and to try and categorize them in any kind of segregation like way, you know, like to have like to delineate one and another would, I think, is a mistake. And I'm obviously interested in communicating my science and things like that, so to try and to believe that I can communicate science that in a way that isn't artistic or isn't, you know, I couldn't present this information how I would present it in a like a poster presentation that I would do for an academic, you know, reason. You have to present it in a way that people who come from all different backgrounds and knowledges, and, you know, whether science or the arts, you have to present it in a way that everybody's going to get. And a lot of times you need the creative artistic process, or the, you know, the humanities process to explain that kind of stuff. I have to use analogies all the time because you know, if I try and explain a process, it, like with DNA, you know, I couldn't just say DNA, because to the scientists they'd be like, yeah, DNA, yeah, I know what that is and I can picture where it is and stuff. But you have to use examples, you know, it's the book of your body that reads instructions and blah blah blah. So yeah, I think to try and separate the two is a mistake. I agree. I think it will become a lot more, let's say, holistic approach. There'll be more integration of arts and sciences. Will come full circle, I think, for sure. And whether that'll be in our lifetime or not, I still think it's useful to use humanities and, you know, what we know of the creative world to assist the scientific world, and what we know of the scientific world to assist the creative world. Yeah. So that was scientific methods and the history of science. I wondered if you wanted to talk a little bit about next time.
Next episode is part 2 of our series on Louis MacNeice's poem Autumn Journal. Part 2 will not make sense unless you've listened to part 1, so I suggest you do that first. Yeah, it should be interesting.
Cool. And that's it for this week. So everybody, we'll speak to you next time.
Goodbye.
Okay, pause that, and I'll pause this. Okay.
Right.
I can